Over the last decade, the global battery industry scaled its manufacturing footprint to meet a single assumption: that electric vehicle adoption would climb endlessly. Companies poured billions into massive, sprawling gigafactories to feed this expected demand. By 2026, that assumption collided with reality. Consumer demand for EVs began to stall as governments reduced purchasing incentives, leaving automakers with a severe mismatch between the cars they planned to build and the cars people actually wanted to buy. We are now seeing the immediate corporate fallout of that miscalculation. General Motors abruptly paused a massive joint venture in Indiana, a project scheduled to churn out battery cells for 300,000 vehicles a year. The contraction extends across the Atlantic. Porsche is shutting down Cellforce, its battery subsidiary, citing a strategic need to step back from heavy manufacturing commitments in a cooling market. This chart illustrates the core macroeconomic problem. You have an exponential capacity growth curve completely overshooting a sharply flattening demand curve. The industry built too much, too fast. We are already seeing bankruptcies resulting from this oversupply, with Norwegian manufacturer Morrow Batteries recently filing for insolvency due to intense global price pressure. The battery sector now faces an existential threat. They possess the raw materials, the engineering talent, and massive production lines, but their primary buyer is suddenly pulling back. To survive, battery manufacturers need a new customer with a massive appetite for power. They are finding it in energy storage systems, or ESS, large stationary battery banks connected directly to the electrical grid to store and release power exactly when it is needed. The grid requires this storage capacity immediately, largely because of artificial intelligence data centers. Training and running AI models consumes continuous, immense loads of electricity, straining existing public utilities far beyond their standard operational limits. Automakers recognize they can sell their idle battery capacity directly to these tech hubs. Ford recently launched a subsidiary called Ford Energy, pivoting a $2 billion Kentucky plant away from cars to instead build standardized 20-foot modular battery blocks for utilities and corporate buyers. Curious, observant tone. Tech companies are also moving to secure their own local infrastructure. SoftBank has partnered with the South Korean startup DeltaX to manufacture ESS units locally in Japan, a direct move to ensure their energy-intensive AI workloads have an uninterrupted power supply. The most lucrative market for battery cells has shifted from the highway to the data center. Legacy automakers and tech giants are finding that high-margin growth now comes from stabilizing the grid for the AI revolution. Pivoting from cars to the grid requires completely rethinking battery engineering. In an electric vehicle, a battery must be light and compact to maximize driving range. But when a battery is bolted to a concrete slab to support a commercial data center, physical weight is completely irrelevant. Because weight no longer matters, engineers can abandon expensive minerals. Instead of relying on costly cobalt and nickel, manufacturers are scaling up globally abundant, exceptionally cheap sodium-ion chemistry. This bar chart shows the scale of the commitment. CAT-ATL is executing a 40 gigawatt-hour production expansion dedicated to commercializing their sodium-ion batteries for energy storage. We are already seeing this cold-resistant, low-cost chemistry deployed in heavy industry. Companies like Jungheinrich are running field trials with sodium-ion batteries in their forklifts, testing how the technology performs in harsh environments where traditional lithium cells degrade. By stripping away automotive weight constraints and swapping the underlying chemistry, the industry can finally manufacture storage infrastructure at a fraction of the historical cost. What originated as a specialized supply chain for electric cars has mutated. The battery industry is now building the foundational power infrastructure for the modern global economy. Chinese manufacturers are moving aggressively into these emerging grid markets, while Western automakers retreat. EVE Energy recently secured an 8 gigawatt-hour storage deal in India, laying down the groundwork to supply up to 60 gigawatt-hours of grid-scale capacity to South Asia over the next 5 years. Others are looking beyond the electrical grid entirely to capture new industrial sectors. BYD has partnered with a Norwegian firm to develop marine energy storage systems, adapting their high-safety battery modules to run large-scale maritime vessels. The largest suppliers are moving beyond exporting cells to exporting the entire structural platform. CATL is supplying its Bedrock chassis technology, an integrated system that builds the battery directly into the vehicle structure, to automakers in Turkey and Europe. embedding their intellectual property into international manufacturing lines. Dominance in the late 2020s belongs to the firms that engineer the power grid for the AI era. Success now requires mastering global energy infrastructure rather than simply perfecting car components. This video is for analytical purposes only and does not constitute any investment advice.